All right, we are in section 3.2 where we are going to solve two-step equations. Basically, it's the exact same thing that we looked at in 3.1, but instead of just identifying whether it's addition, subtraction, multiplication, or division, there are going to be instances where we're going to use um, both operations to help us solve any particular equation. Anytime you have two-step equations, the first thing you have to identify is whether you have to add or subtract the equations on both sides, and then once you've done that, then you're going to see if we're going to multiply or divide. So just like always, when you're working with opposite sides of equal signs, you're going to use inverse operations. The same side of the equal sign requires using the same operation given, so you're going to be combining like terms whenever necessary. So looking at examples such as these, um, for A, it's 9x plus or minus 11 equals 79. So the first thing we have to identify is it addition or subtraction? Since there's subtraction, we have to add both sides by 11 first. Once we do that, this gets canceled. So now I have 9x equals 79 plus 11 gives us 90. And now this is a multiplication. So we're going to divide both sides, which then x is going to give us 10. Okay. Looking at B, again, this is addition here, so that means you're going to subtract 15 from both sides. So this cancels. Now I got negative x divided by 6 equals 8 minus 15, which gives us a negative 7. Finally, since we have division, that means we're going to multiply both sides, and it's going to be by a negative 6. And this will cancel both sides here to give me x is going to equal a positive 42. If we look at C, I have negative 3x minus 22 equals negative 37. So here we're just going to add 22 to both sides, which then gives us negative 3x on the left-hand side, and negative 37 plus 22 gives us negative 15. From here we divide negative 3 to both sides, which means x is going to equal a positive 5. Okay, looking at D, we have 42 minus x equals 36. So since there's no sign here, we assume that it's positive, so we subtract 42 to both sides. We have left over on the left-hand side is that minus x, so it's essentially negative x, and it's going to equal 36 minus 42, which gives us a negative 6. So now it's the x isn't by itself. It's got the negative attached to it. That negative is the same thing as writing negative 1. So to get rid of the negative 1, I'm going to divide both sides by negative 1, which gives me a positive x over here, and it gives me a positive 6 on the right-hand side. Now, same thing goes for these values here. Just because they're decimals doesn't change anything. You're just going to add 3 to both sides here. So I have 0.15x on the left. It's going to equal negative 0.75 plus 3, which gives me a positive 2.25. And then from here, I'm going to divide 0.5 to both sides. When I divide 0.5 to both sides, I get x equals 15. Okay, looking on to example F, here we're going to add 12 to both sides here, which gives me a negative 3/8 x equals, looks like 6 plus 12 is 18. I multiply by a negative 3/8 to both sides here. From here, I'm just going to multiply it across. 18 times a negative 8 gives me a negative 144 divided by 1 times 3, which is 3. divide everything by 3. Negative 144 divided by 3 is a negative 48. So that's my value for x. Now, most people get really, really nervous when they look at an example like g, because you have multiple fractions in a particular equation. If fractions make you nervous, let's get rid of them. So what I'm going to do is I'm going to multiply the entire equation by the least common denominator of our fractions. Well, since it's 4, I'm just going to multiply the entire equation by 4. So I'm going to distribute this 4 to each of the terms inside the equation. So 1/4 times 4, when you're multiplying together, you get 1. So 1, which just means I just get x, plus 7/4 times it by 4. The 4's cancel, so now I just get 7, and it's going to equal 10 times 4, which is 40. Now x plus 7 equals 40 looks a lot easier to solve rather than the 1/4 x plus 7/4 equals 10. Now I just subtract 7 to both sides, and x is going to equal 33. Okay? Looking at h, here, right off the bat, on the same side of the equal sign, I have like terms on my left-hand side, so I can combine negative 18x and positive 14x to give me a negative 4x, which is going to equal my negative 52. And then from here, I just divide negative 4 to both sides. So negative 52 divided by a negative 4 is going to give me x equals a positive 13. Okay. Next section here, it says finding an input for a function. So if you were to remember about input and output, input is always our x values and the output is our y values. So keeping that in mind, the statement says the output of a function is 4 more than 6 times the input. So they're asking to find the input when the output is 48. So they're already telling you that y is 48. They want us to find x. And they're telling you that in order to find the output is going to be 4 more than 6 times the input. So 4 more talks about addition, so it's going to be 4 plus 6 times the input. Well, we know that the input is x, so we're going to say that's x, and that is going to equal y. So that is the formula that we're going to use in order to solve this particular problem. Well, now to find x, we know that y is going to be 48, so I'm going to go 4 plus 6x equals 48, because that's what they told us that was right here. From here, we're going to solve for x, so we're going to subtract 4 to both sides here. I get 6x equals 44. Final step, we divide everything by 6. 44 divided by 6 gives me x is going to equal either 7.3 repeating, or if you wanted to write it as like a fraction, you could say it was 22 over 3. Okay? So here are some word problems here to kind of see if we can use what we know from solving two-step equations to kind of help us find out what we need to do for these particular problems. So this one is read: to rent a booth at the county fair cost $42 per day, plus a one-time equipment fee of $85. Find the number of days Mr. Smith would have a booth if he paid a total of $337. So right off the bat, they're saying that it's going to cost $85, and that doesn't change whether you're there for like 1 day or 5 days or 6 days, whatever. So that doesn't really have a variable attached to it. So then it's going to be added to the $42 per day. So $42, but we don't know how many days it was, so I'm going to make that my X. X represents the number of days Mr. Smith had rented a booth at the county fair. And it says in the problem that he paid $337. So we know he paid $337. We just don't know how many days he was there at the county fair. So from here, we're going to subtract 85 from both sides. This gets canceled, so now I have 42x equals 337 minus 85. That gives me 252. Divide everything by 42, and that gives me x equals 6 days. Okay. Looking at the next example here, it is as follows. It says Tina works for commission at a auto dealership. She gets a flat rate for each of her shifts of $120 and also earns 1.5% commission on each vehicle she sells. Tina made a record for earning her company the highest grossing sales in one day ever by a single employee. She also did pretty well for herself. How much money did she earn for her company if she walked home with a total of $1,380 for the day? So if you look at the problem, it says that she gets a flat rate. Each of her shift is $120. So if she sold like 0 cars that day, that's how much she would make. So there's no variable attached to it, so we're going to say 120 plus. We know that she makes 1.5% commission on each of the cars she sells. So if we convert the percentage to a decimal, it's going to be 0.015 as a decimal, which is equivalent to 1.5%. And then we don't know how many cars she sold, so that's going to be the value for X. Well, actually, we don't know how much money she made from those cars she sold. I'm sorry. So that's going to be the value for X. But we do know that she took home $380. So from here, we get to subtract 120 from both sides. This leaves me with 0.15x. That's going to equal 1380 minus 120. Then that's going to be 1260. Final step is to divide 0.15 to both sides. And that gives me x is going to be 84. Oh, I'm not writing it right. Here, let me erase that. Let me move this down a little bit. So x is going to equal $84,000. So she either sold a really expensive car or a couple really nice cars or several fairly standard cars. And that is being able to solve two-step equations. Hope this helps. Until next time.